In this section, we begin to explore JSON and data operations. We'll begin with an overview of JSON, which stands for JavaScript Object Notation. We then review the structured but schemaless nature of MongoDB. With that foundation, we then get familiar with the mechanics of adding and querying, including some advanced query constructs such as sort, limit, and projections. In this video, we start with an overview of JavaScript Object Notation, known as JSON. Resources used in this video include the main JSON website, json.org, a text editor, and an online JSON parser that is very useful in examining and crafting JSON objects. We also learn about BSON, which is binary JSON, including some of the data formats in MongoDB that leverage this binary format. We'll also discover that JSON has broad programming language support. json.org is the official website for JSON. JSON is a data interchange format, not a programming language. Unlike XML, JSON is lightweight and fast to process. It is also more compact than XML, which reduces overall network strain. JSON is also easy for humans to read and has a refreshingly simple definition. In fact, the entire definition is contained in the 5 images below. JSON is built on 2 building blocks: a collection of name-value pairs. An object begins and closes with curly braces. Name-value pairs exist on each side of a colon, with the name always on the left. Multiple name-value pairs are separated by commas. Names are always strings. An array is an ordered list of values, separated by commas and contained inside square brackets. A value can be a string, a number, and even another object, also called an embedded object, an array, a Boolean value, or null. Strings are contained within quotes and can include any Unicode character, including a number of special characters that require escaping. A number can take any form, including exponential notation and floating point precision. Now we'll look at a few example JSON documents. In this first example, you'll see that we have 5 name-value pairs. The names, which you can think of as keys, are name, email, major, test scores, and course GPAs. The values include 1 embedded object with 2 name-value pairs, and 2 strings, and 2 arrays. Notice that JSON can be represented easily in plain text, just like XML. Let's copy this object, and we can use an online JSON parser to more closely examine the object. The instructor object is a little more interesting, so let's copy this and paste it into our online JSON parser. Here we also have an embedded object, and now we have 2 array values. Let's add some course numbers to the course values. You'll notice that as the parser finds errors, it highlights them. This is very fast and makes it effortless to craft objects that represent valid JSON. The same element that allowed us to enable beautification of JSON documents will also enable us to show types and indexes. As you can see here, the array is shown as 0-based, even though JSON doesn't define a direct access mechanism. That may be different. The indexing of array elements may be different depending on the specific language drivers you're using and the data type used to map arrays. This view also makes it obvious to see embedded objects and other data types. Now let's learn a little bit more about BSON on mongodb.org. BSON is an extension of JSON which adds some specialized types and accommodates some performance enhancements and space efficiencies within the MongoDB engine. Notice that there are many more binary data types than there were JSON types. This is to accommodate storage and query of common types, such as date and object IDs. Here in our text editor, we have a sample BSON document, which includes a MongoDB-generated object ID. When we copy this into the JSON parser, we quickly see that MongoDB's representation of an object ID does not conform to standard JSON. This is important because it reminds us that in order to manage BSON documents suitable for MongoDB requires a MongoDB library or client. Up to this point, I have referred to JSON objects. MongoDB refers to them as documents. Throughout these videos, you may hear me use the terms object and document interchangeably. They refer to the same thing, a JSON object. For now, we'll clear out the object ID and make an important observation that MongoDB doesn't care about quotes. For example, if I change the email to show without quotes, the JSON parser complains that it is invalid. However, MongoDB would interpret email as a valid name for the value john.shore@gmail.com. Back on the JSON.org website, it's helpful to notice that JSON enjoys broad programming language support. These include popular languages like Python, C#, Java, and Objective-C. It also includes more special-purpose languages such as Erlang, R, and LotusScript. In this video, we explored JSON by using a text editor and an online JSON parser. We also learned that libraries have been created for many programming languages to support the use of JSON. In the next video, we'll look at what schema and structure mean in MongoDB.